Hello, ladies and gentlemen. Welcome to section 5 of chapter 6. We're talking about division property of exponents. We've already talked about multiplication properties of exponents. Now we're going to do division. Division is basically just the opposite of what it was with multiplication. Um, Multiplication, we multiplied the big numbers and then added the little ones. Now with division, we're dividing the big numbers and subtracting the little ones. So we see here we have the bases are the same. We have m and n, m divided by n. Because they were exponents, our base stayed the same. We subtract m and n. So let's take a look at a couple different examples here. We've got 6x to the ninth divided by 3x to the fourth. Okay, so what we have here is we've got a case where we have x to the ninth and x to the fourth. And then we've got big numbers 6 and 3. Okay, so our rules for division property of exponents says we take our big numbers and we divide them. So we're going to take 6 divided by 3. That's going to give us an answer of 2 for our answer there. We also have x to the ninth divided by x to the fourth. That tells us we're going to take 9 minus 4, and that's going to give us 5. So we end up with x to the fifth as our answer there. Okay. How we're also going to see this is we talked about expanded form prior to this, and this is going to help us see what we've got here. So we've got 6 times we have 9 x's here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 3. 1, 2, 3, 4. Okay, so in this expanded form, we'd have 6 divided by 3, that gives us our answer of 2. So now if we see here we've got x's and we can cancel those out. So we have 4 x's that we can get rid of. That leaves us with our 5. So we have x to the fifth. And notice we see that those answers do in fact match. Okay, so now let's take a look at this next example. We have 4 to the fourth, x to the ninth, y to the fourth, and then we have 4 squared, x squared, y. Okay, so in this case, what we're going to do is we're going to take, we have 4 to the fourth, we have 4 squared. Because these bases are the same, the 4's are the same, we're going to leave that 4. We're going to subtract 4 and 2, which is going to leave us with 4 squared. Then we also have x to the ninth over x squared. Bases are the same. That means we subtract our exponents. We have x to the seventh. Okay, and then the last one, we have y to the fourth over y. Remember, if it's just y, that's implying that's y to the first power. That gives us 4 minus 1, so that gives us y to the third. So our final answer, you can write it in 2 different ways. 4 squared, x to the seventh, y to the third. Or we can simplify 4 squared, which is going to give us 16. We have x to the seventh, y to the third. So either one of those answers would be satisfiable for myself. You just have to make sure that you understand how we got those types of answers. Okay, now we can also have these types of deals with scientific notation. So we've got 7.5 times 10 to the eighth over 1.5 times 10 to the third. This we still treat the same way. We're going to take 7.5 divided by 1.5. Big numbers, we divide them. That gives us 5.0. Because it's scientific notation, we have to have it times 10. And then we're going to take our exponents, and we're going to subtract those. So 8 minus 3 is going to give us to the fifth power. Okay, so let's take a look at this next example as well. We've got 4.8 times 10 to the fifth. And then we've got 2.4 times 10 to the negative second. So we take 4.8 divided by 2.4, that's going to give us 2.0. We're going to times that. We take 5 minus negative 2, that turns into plus, so that's why it's going to be 10 to the 7th. Okay, so we have to make sure that we do the right subtraction rules there. And there we have it. Okay, so this is division property of exponents. It's very similar to what we've been doing with multiplication properties. It's just opposite ideas as far as addition and subtraction goes. If you have any questions, make sure you let me know. Have a good day.